In summary, with a single prompt, JasperNode generated the control logic for the entire system. This was achieved by creating individual tags and assigning specific scripts to it. All these tags with green icons indicate the script was assigned and enabled. And when the system misunderstood us, AI helped to troubleshoot and rectify the issue successfully. Hi everyone, my name is Alex, and I'm here today to show you a short demo of an innovation and new technology we developed here at ControlX. It is an AI-powered software designed to simplify the creation of control logic for your automation system. We call this software JasperNode. Using JasperNode, you simply describe what your system needs to do in plain English, and that JasperNode translates it into the functional code. Using your existing PLC system or any other remote IOs, it executes the functional code. Using this demo box, I'm going to show you how it works. So this is the demo box layout. In the left top corner, you can see mini PC with JasperNode installed. On the right top, this is a PLC, but we use here as a remote IO, and other remote IOs can be used. There are two digital inputs, one analog input. There is an analog input behind this cover as a temperature sensor, and this is our analog output. There are a few digital outputs. Here you'll see as LED, but also this cable leads to the LED tower. So this is a brief description of the video. We're going to create a script and a tag manually. We're going to create a connector and control logic using AI Assistant. And if anything goes wrong, I'll show you how to troubleshoot using AI Assistant. Once logged in, you'll be at the main screen of JasperNode. The main interface is very simple. Menu on the left and workspace in the middle. You use automation design to view tags and set scripts and modify properties. Here, the list of connectors we can set up. Let's get started with creating a tag with a basic script manually. To do so, I click on the plus icon, go ahead and give it a name. So now in this folder, I can see the tag created. Let's say we want to create a simple script for this. Click on the plus button, and here we can paste the script we prepared earlier. So what that script does is when the second is passes 0 or 30 in every minute, it increments by 1. We only need to add the triggers. Save the script. And here we either type to see the tag or go and open the tag to drag and drop here. Press deploy, enable the script. And now every time it passes 30 or 0, this tag will increment by 1. Yeah, this is the basics of the scripting in JasperNode. Let's continue with programming of our application and create the control logic using the AI Assistant. Click AI Assist. Yeah, this is how the chart looks. This is the main chart area, and there will be a list of charts as we have some history in the future. The one important feature of JasperNode is that it has the documentation inbuilt into the AI Assistant. If this is your first time using JasperNode, type how to get started with JasperNode and just hit enter. This is a typical workflow of using an AI assistant. Take time to read and to become familiar. It describes the key concepts and provides an example. So now we need to read and write data to our remote IO. So we need to create a connector. We could close this, go to the PLC connector, by pressing plus, create a connector. But it is easier and more convenient to use an AI assistant. So we'll go back to our AI assist. And in new chat, we type create a connector to S7-1200 PLC as the controller's remote IO with the following IO list. And here we can go back to our spreadsheet where we have prepared the IO list. We simply copy this and paste it in the chart. As we can see, AI is starting to read in the existing connectors, looking for what exists and if it needs to be modified or create a new one. It's following through internal thinking and logic to create a connector as per our instruction. As we know the IP address, we would like to modify this and enable the connector. The AI following the instruction and doing the IP change and enabling it. Let's close it for a moment. Let's test the connector by reading the values and writing to output. Let's look at the demo box in the left bottom corner, and we can see the inputs from our temperature sensor and from our set point. Let's modify this value all the way to 0 and all the way to 100%. Let's check the inputs. The manual, auto toggle, and the system on off. Let's go ahead and test our outputs. The fan output. The fan is spinning. Let's go ahead and test our digital outputs. The system is active. It's green. Heat is on red and yellow. Now let's create the logic for the temperature controller using AI Assistant. Here, AI Assistant chat. Similar how we created the connector, we will use AI Assistant to help us. In one of the tabs, I prepared the operational instruction, or also called function specification, and it's a good practice to use it as your initial prompt. I'm going to copy and paste this text, and let's go ahead and press enter. As you can see, the response generation is quite rapid. It's going through understanding the system, understanding the requirements, and creating necessary tags. Also, it's updating the necessary tags to attach scripts to these tags. So in the end of the response, there is always a summary and a few follow-up questions. Briefly scroll through, we can see it did a good job. Let's test the system. So let's start with the temperature and see if it scaled temperature correctly. Sensor underneath the cover, and it seems correct. Temperature set point, it goes all the way from 0 and all the way up to 50. Let's try the system by turning it on. We're going to set point to, let's say, 15 degrees. Let's turn on the system. The fan started spinning and yellow light came on. It works correctly and is per functional specification. Let's start increasing the set point to 30 degrees and see how the system behaves. So here we can see it worked exactly as we specified. Now let's try manual control. But before, let's open our outputs. To see the system switches to manual mode, we have to switch the system off and once press the manual auto button. Here we notice that the system didn't change to manual mode. It only was manual while it was pressed. Let's try to troubleshoot this and ask AI to fix this. We have two choices. We can go either locally with the AI assist on this particular script, or we can go on the main one and continue the chat. Here we can ask to fix our manual button. This is how our prompt is going to look like. So the AI goes through existing tags and scripts, and it will identify the bug and the problematic script, and it will change it for us. It provided quick summary. It looks correct. Let's go ahead and test it. As we can see, it's changed to manual mode. Fan speed set point went to the value that's changed. Modifying this value, you can see the speed of the fan slowing down and increase the fan speed to 100%. on-off button, heat is activated. So the manual mode operates exactly as we specified in our prompt in a functional specification. In summary, with a single prompt, JasperNode generated the control logic for the entire system. This was achieved by creating individual tags and assigning specific scripts to it. All these tags with green icons indicate a script was assigned and enabled. And when the system misunderstood us, AI helped to troubleshoot and rectify the issue successfully. As you can see, AI can rapidly generate control logic for industrial systems. To discuss how this technology can be applied to your specific application, please contact us directly. Thank you for watching, and bye-bye.